Before I proceed to some illustrations of examples of algebra of a subset of a given set, let's say X later, let us also talk about these implications for our definition for algebra of sets. Now, this is the definition in the previous video. We already discussed this, but let me also write it here for some basis of our discussion for this item that we are trying to prove. This definition: let X be a set which is not equal to empty set, and say let a certain script A, which is a subset of the power set of X, where script A or set script A is also not an empty set. We can say here that the script A is an algebra or algebra of subsets of your set X, as it is the set here identified. Let's make this bigger. Okay, if it satisfies the following condition. Okay, so we have two conditions as discussed on the previous videos, and we are rewriting them here for your guidance, or you can also revisit that if you would like to. The first one here is if certain A and B are element of your script A, this implies that their union must also be an element of your script A. This means that it's closed under finite union. And the second condition that says that if A is an element of your script A, this implies that its complement is also an element of script A. These are the two conditions for us to say that our script A is an algebra of subsets of set X. If one of these two will not be satisfied, then definitely script A is not an algebra. Now, let us say here that what we're trying to prove is already stating that our script A is already an algebra. Now, let's assume, okay, we are going to assume here that A is already an algebra on a certain subset of any given set. Okay, so take note that what we are trying to prove here is this. We are trying to show the complement, the intersection. Yes, the union is given by definition, the complement is given by definition, but one of the implications for this is that the intersection of those given sets, or finite intersection, should also be contained in our script A. So that's what we're trying to prove here. So let us have here the proof. First, let script A is an algebra. Okay, or let's make it generalized. Let's not use here X, but let's make it an general statement that script A is an algebra, meaning these two should already be satisfied. So what we're going to show is from any of these two statements, we will end up with the intersection be also contained on our script A. Now, of course, we will be using A and B because it is part of our condition. So we are going to let A and B be element of your script A. Okay. So again, our goal is to arrive at this conclusion that may use any of these two conditions already satisfied, being this already claimed as an algebra. Now, let us go to the idea of A2, the condition of A2. Okay, by A2, since we already know that it's an algebra, if A and B are elements of script A, that would mean their complements, according to your A2 here, must be also contained on our script A. That would mean A complement and B complement must also be element of script A, because again, we already let script A be an algebra. So what could we say here? This follows. Let us try to look into this perspective here, that we are going to attack the complement. That would mean, okay, that if you're going to, according to A1, okay, this follows by A1, the first condition, if these two are elements of script A, then their union the union. So the union of A complement and B complement must be an element as well of script A. Take note, for the first statement, we used A2 to make sure that the complements are also element of script A, and by A1, we can say that their union must also be a complement, element of script A. Now, what can we further say that from this statement of union, the complement will arrive? Take note that we have here, okay, by De Morgan's law, if you can still remember De Morgan's law, there are two statements of De Morgan's law. Let me rewrite right here the statement. Okay, De Morgan's law tells us that the what do you call this one? The union or the complement of the union of any two sets is just equal to the intersection of their complements. At the same time, the second statement of De Morgan's law, the complement of their intersection is just equal to the what do you call this one? The union of their respective complements. This is according to De Morgan's law. Okay, the union or the complement of the union is equal to the intersection of their complements, or the complement of the intersection is equal to the union of their complements. Now, from this part here, since we're able to establish that the union of their complements of A and B, okay, their union is an element of A, that would mean, according to De Morgan's law, specifically this second statement here, this one here, okay, this would mean that its equivalent, which is the complement of their intersection, okay, this one here, is also an element of your script A, according to De Morgan's law. Okay, that's according to De Morgan's law. Now, finally, once we arrive into this, take note that if this exists in A, in short, then its complement, so we have the complement of A intersection B complement. This would mean that this being the complement of that, and according to A2, since the complement of a certain set also is contained to script A, and since this entire expression is already an element of script A, its complement is also an element of script A. And by the way, what is this equivalent to? When we say the complement of the complement, it would mean this expression itself, which tells us, hence, A intersection B is just an element of your script A. Okay? And this is what we're trying to show for this implication. It's not declared in a definition of the algebra of sets, but with the use of those two conditions and De Morgan's law, we were able to establish that from all these arguments, the intersection of A and B should also be an element of script A, which tells us that there is a possibility that the finite intersection of sets, as long as they are element of set script A, which is already identified as an algebra, that would mean it is already closed as well under finite intersection. We will have another implication to be discussed in the next video. Thank you very much for watching.